This is a video for the frequently asked questions from section 2.5, day 2, the things that we had to use the graphing calculator for. And with number 13, it says the table shows the relationship between the production of the export of rice in Vietnam from 1985 to 2005. And the thing that is going to mess up the math here for all of us is the fact that both of these are in terms of 1,000 tons. So this one always messes people up because of that. And it says, how much rice would you expect Vietnam to export in 2015 if the production that year is 42,250,000 tons? So as it says here, how can you use a scatter plot to find a linear model, and how can you use your model to make a prediction? So what we would do is we would go into our graphing calculator and we would get this in. And my graphing calculator has disappeared. All right, now that I got my graphing calculator to pop back up, we go into Stats, number 1, Edit, and just to save time, I went ahead and put all of those numbers back in. Now, as I put that up there, I'm thinking, 59, was that right? I mean, look at all those numbers in list 2. But yeah, if we double check the data, that's what it was. So what we want to do is the linear regression to get our model. So Stats, arrow to the right once to calculate, and then number 4, linear regression. And I do have my information in list 1 and list 2. I'm not going to worry about storing it, and I want it to calculate. And there it is. So this is y equals ax plus b, where it's going to be about, I'll go 3 decimal places this time, 0.218x minus 3,157.593. So that is our linear model, and it's a pretty good one. If you look at R, 0.96, that's a really good model. So let me get that written down. My 0.218x minus 3157.593. All right, so there's my model. And since I have the model, I want to go back to the question of how much rice would you expect Vietnam to export in 2015 if the production that year is 42,250,000 tons. Now, this is in those thousands of tons. Remember, that's there. So to use the formula, we actually have to take off those 3 zeros to put that number back in. Now, 2015, that's what's called a distractor. That number isn't even something that's on our chart. So what we have to focus on is that production was our X, and this is production, and it's in thousands of tons. So we have to make X 42,250. So this one I'm just going to punch into my hand calculator here in the room because this is just multiplication and subtraction. So 0.218 times 42,250 minus 3,157.593. And that comes out to 6,052.907. But again, we have to remember, okay, but this is in thousands of tons. So now I have to put those 3 zeros back on, which means I'd have to multiply this by 1,000. And when you multiply something by 1,000, all you do is move the decimal over 3 places. So it would be 6,052,907 tons. So in this problem, It's not that people can't, punch everything in right and correctly. What's happening is that the label is going to mess with everything that we do. And yes, if you check that with the book's answer, it's going to be a little bit off, but that's okay because again, we're using a graphing calculator to do our linear regression, and they might be using a computer program. So being a little bit off is perfectly acceptable for some of these. Now, the next one that I realized after the fact, you might not know how to do. I'm hoping you do, but if you don't, number 22 says, which equation does not represent direct variation? Direct variation is a situation where you're always paying the same amount. For instance, if you're going to go to the movie theater, you would use y equals 7x to monitor that because the movie theater is $7 for each ticket. So if you want to know how much you're going to pay for 5 people, you take 7 times 5. So what we have to do is look at each one of these and see, well, which of these doesn't just have multiplication taking place? So A is fine because that's like an imaginary little 1 there. But if I were to solve for y in B, I would have to subtract 2x from both sides, and I can see already I'm going to have a plus 5 hanging out in back, and that's not okay with direct variation. It just has to be multiplication. So that's the one that is not direct variation. The others, if we solve for y, we would see they do come out to be direct variation. For instance, in this case, if we just take our 2x minus y equals 0 and we add y to both sides, we see 2 times x is y. And for D, if we add 5y to both sides, we get 2x equals 5y, and then we could divide by 5, and even though it's a fraction, it's 2/5 x equals y, it still is direct variation. You're still just multiplying to make that happen. So those were the two that I wanted to make sure I did for the FAQs.